Hello everyone, my name is Paul Roberts and I am a Class D water treatment facility operator here in the state of Missouri, as well as a Class DS3 water distribution certified operator. Today I'm going to be discussing the water treatment facility sampling and testing processes that go on at the Lilburn Water Treatment Facility. The purpose of this training is to specialize new water treatment operators for the Lilburn, Missouri Water Treatment Facility to ensure that they are aware of the daily samples and testing that go on and ensure that they're properly trained. As I said, who should attend or who should take this course and why? It would be new operators to the Lilburn Water Treatment Facility so that they understand what tests are being ran on the water samples daily and kind of understand what the process is that goes on at that particular facility. I'm also going to discuss, I have 4 training objectives. They are to set up the samples that are going to be tested. We'll probably see how to operate the Hawk DR 900 colorimeter, analyze and understand these results, as well as the importance and impact of each of these tests that are ran. Okay, we're going to begin objective number 1, which is setting up samples to be tested at the water treatment facility in Lilburn, Missouri. First off, for all these tests, you're going to need a blank, which is a vial of distilled water, 10 milliliters of it, and then you're going to need another vial of 10 milliliters of your sample water. Be sure that the bottom of the meniscus reads at the 10 milliliter line, whether you're using a large or the small vial. Either way is fine. Just be sure that you've got 10 milliliters of sample or distilled water, depending on what you're trying to do, whether you're setting your zero out your machine with the blank or actually testing the sample water for the item that you're testing. As I said, you take your 10 milliliter vial of distilled water and then grab whatever packet you're wanting to test for, whether it be free, total chlorine, iron, or manganese. Tap on the pillow or packet to ensure that all the granules go down to the bottom of it. I like to cut it open to be sure I get a good even cut. Squeeze the packet so that you've got almost like a funnel, so that you can pour the granules into the container. Pour your pillow into your blank. Put the lid back on. Again, this is the 10 mils of distilled water for the blank, as well as the packet of reagent for the test that I'm wanting to run. Wipe off your vial to ensure you have all of fingerprints and any moisture that may be present there. Just stir it up, shake it up, make sure it's stirred up good. And then you want to take your other vial. In this case, I'm going to be using testing for the total chlorine. Same thing, tap the packet, make sure you get all of it to the bottom. Cut it open, get yourself a good pouring, almost a funnel. Pour it into your sample water. Put the lid back on it. Wipe it of all fingerprints and all moisture. Stir it up, shake it up, get it good and dissolved. Make sure that the reagent is very good and dissolved. And I don't know if you can tell or not, but when you're testing for chlorine, the water will turn sort of a pinkish color, which is an indicator that chlorine is present. Then you carry on this procedure for each of your tests, whether it be free, total, iron, and the only exception is manganese. Manganese, you'll use 1 packet of absorbic acid, and it's labeled right here on the packet, very easily to tell. One packet of absorbic acid to and 12 drops of alkaline cyanide reagent, as well as 12 drops of pan indicator solution. Shake them up, put both of those in the sample as well as your blank, as well as the pillow of absorbic acid, and you're good to go. One other thing I wanted to be sure to point out, when you're running these tests, don't use the same samples or the same blank of distilled water for each test. Be sure to clean out your vials and get a fresh sample before you add the new pillow for testing each test. And be sure to clean out the vial for your blank and get a new 10 ml sample of distilled water for your blank. Okay, now we're going to begin objective number 2, which is properly operating the testing equipment, or in this case, their Lilburn is the Hawk DR900 colorimeter, which can measure chlorine, the free and total amounts, iron, and manganese. Hopefully you grasp objective number 1, which was setting up the samples. If not, we're going to go over just a little bit more during this in order to operate the machine. First off, like I pointed out, here's the machine. This is just your cover, and your vial is inserted into this point here. Always point your vial. There's a diamond located on the vial. You want to point it towards the front of the machine or towards yourself when you're reading it. There is an on button at the bottom of it. Comes on. Currently it's set to test for chlorine free and total. Ways of getting around. You've got your options button here. Select options. If you're doing a test that requires a timer, you can hit select and it starts the timer for the chlorine. Or you can go to favorite and user programs, hit select. You can choose 290 manganese LR pan, which is what we use to test for the manganese there at Lilburn. Or you can go to 265 iron ferrous ever, or 80 chlorine free and total parts per million. You just whichever option you want to go to or test you want to run, go to it and hit the start button, and you're set up ready to go on that particular test. As part of Objective 2, operating the test equipment, or the DR900 in this situation there at the Lilburn Water Treatment Facility, once you get your results from whatever test you're doing, you want to be sure and log them on the daily ledger sheet. This is always labeled in milligrams per liter or parts per million. They're in the water world, they're interchangeable. So I want to be sure and stress every day, every test you run, be sure and document it on this daily ledger sheet so that it is documented what results come from the test that you run that day. Okay, now we're going to go a little bit more in depth on operating the DR900 colorimeter and operating it. For right now, I'm going to run a test for the manganese. So I've got a 10 ml sample of distilled water, and I've got a 10 ml vial of sample water. Again, I'm going to take my 2 pillows of absorbic acid, be sure to knock the granules down to the bottom, cut them open, get a nice V-notch so you can pour the granules into the vials easily. And then you add 12 drops each of the pan indicator solution to each vial of the sample water as well as the distilled water or the blank. And then you need to add 10 drops of the alkaline cyanide reagent as well. I said 12 drops, right? 12 of each. With the manganese, there's a 2-minute timer. So once you've got your meter set to test for manganese, go to options, start timer, select, and then select again for the 2 minutes. And then your 2-minute timer begins. Put your lids on your 2 vials, and you want to shake them up thoroughly. I don't know if you can notice it, you can tell it or not, but here in my right hand is the sample test, the sample water, which usually when there's an indication of manganese is a little bit darker. They both look pretty well similar color at this point, but I can tell my sample is going to have a little bit of manganese. And at this point, we wait out. We got about a minute left, and we'll resume here shortly. Okay, our 2-minute timer just went off. Once you get all your vials completely dissolved, get the granules very good and dissolved, the reagents good and dissolved. Be sure and clean off the vials. Point the diamond towards yourself. You've got approximately between 2 and 6 minutes on this test for a good shelf life for this test, the sample. Place your blank into the machine. Put the lid back on the machine, and then you want to hit the 0 button. It should give you a comeback with a 0 reading. 0. Once that's done, again, your diamond facing you in the machine. Put the lid back on, and you hit the read button. Be sure and keep it blank on a flat surface so it gets a good reading. 0.07, which is a very good reading for manganese this far out in the distribution system. Okay, the next I'm going to continue on objective 2 is operating this meter. We're going to test for the iron level in the water here at my house. You've got your DR900. We need to change the settings to go to the iron test, so you choose options, favorites, user programs, and then we're going to go to 265 iron ferrous ver, and then hit select start. And at this point I'm going to set up my samples. Again, when you're setting up your samples, you take a 10 ml vial of distilled water, which has supposed to have no contaminants in it, as well as a 10 ml vial of your sample that you're going to test. Take a packet of the pillow of the iron amphetamine, tap it to get all the granules to the bottom. I know it's kind of over and over, but it needs to. You need to get all of this packet into each of these vials. Cut open each packet. You need 1 pack of iron for the distilled or the blank. Make sure you get all the granules inside there, and then another packet for your sample. There's a 3-minute wait time, so once we get this in here, we're going to go ahead and start the timer. Again, go to options, select start timer, and select again, and that starts your 3-minute timer. At this point, I'll put my lids back on the valves to start getting the reagents dissolved into the water. Ensure we get accurate readings. Like I said, this is a 3-minute timer, so I'm going to pause the video and we'll come back here in a minute. Okay, our 3-minute timer is up. Again, you've got between 3 and 6 minutes to run this test. That's the shelf life of the reagent and the sample before you get inaccurate readings. Again, you're going to take the diamond facing yourself, going towards the front of the meter, insert it into the meter with your blank. This should read 0, so we should be zeroing out our meter at this point. Put the lid back on, place it on a flat surface, and hit the 0 button. Zeros across the board. Take your blank out, put your sample in, again the diamond facing the front of the meter, lid back on, and simply hit the read button. .06 milligrams per liter or parts per million. They're interchangeable in water terminology. And the maximum contaminant level for iron is 0.3 milligrams per liter. So with the 0.06, we're well below that threshold or that limit. And the iron level is good in this water in this situation. We're going to continue on with objective 2, operating this DR900 colorimeter, and we're going to move on to the testing of free chlorine residual in water. Again, this test takes a 10 ml sample of distilled water and a 10 ml sample of your sample water, 1 packet of the free chlorine reagent for each vial. Get all the granules to the bottom. Cut it open. Pour the reagent into each vial. Make sure that you get all the granules in there so you get a good accurate reading. On free chlorine, there's no wait time, so as soon as we get these pillows popped in the vials and dissolved well, we're good to go. I'm going to shake them, swirl them. I don't know if you can notice the difference in the color here. The one on my right is my sample vial versus the one on my left is the distilled water vial or the blank. This one has a sort of a pinkish tint, as I said. Chlorine with the presence of DPD, which is the reagent used to determine how much chlorine is in the water, turns a pinkish tint. Like I said, no wait time for free chlorine, so we're going to go ahead and change the meter to the chlorine test option. Go to options, favorite user programs, select, down to 80 chlorine free in total, start. Remove the lid, insert the blank. That has distilled water plus the free reagent in it. Place it on a flat surface, zero the machine. Hopefully we get zeros. 0.00 milligrams per liter of Cl2. That's free chlorine. Going to insert the sample vial, diamond facing me. Place the lid back on. Hit the read button. 0.74. That's pretty decent. I'm at the end of the distribution system where I live, so the DNR requirements is a 0.2 milligrams per liter minimum at the end of a distribution system. 0.5 there we're at the water treatment facility, so we're well above those lower range specs, and DNR also has a higher range of 4.0 milligrams per liter, and we're well below that. So generally anywhere between a 0.5 and 2 in most water systems is considered a decent chlorine level. Now we're going to begin testing and running the DR900 on the total amount of chlorine in water sample. Again, a 10 ml sample of distilled water and 10 ml vial of your sample water. Nothing new there. 2 pillows, 1 for each of the vials of the total chlorine reagent to dissolve and tell us what our chlorine residual is. Dump the packets, cut them open, pour the pillow in each one pillow in each vial, the blank as well as your test sample. Ensure that your meter is set on the 80 chlorine free in total parts per million. There is a timer here, so we want to go to options, start timer of 3 minutes, select. So that starts your timer. We've got the reagents in each of the vials, and we'll start mixing them up. And because there is that 3 minute timer, I'll come back to you here in a few minutes. Again, maybe you can see the pink discoloration here. Maybe I'll get a little closer. You can tell that my sample water is turning pink because of the DPD, or the reagent that's actually used to determine how much chlorine is in the water. And once again, we'll be back in a few minutes. And we're back. The 3 minute timer is up. Once again, take your 10 ml sample of distilled water, which is going to be your blank or 0. Wipe all the fingerprints off and all of the moisture that may be there, any contaminants that may be on it. Diamond facing you into the meter. Place the lid back on it, just as this, and hit 0. And it should come back with all zeros. 0.00. Now we've got our sample vial. Like I said, you got between 3 and 6 minutes to run this test once you start mixing the reagents with the sample. Place it into the meter. Lid goes back on, just like this. Read button all the way to the right, and hopefully it'll come out higher than what the free was. 0.81. That's a 0.81 milligrams per liter for your total chlorine. Usually they like to see 85% of chlorine as free chlorine as opposed to total. That meaning that there's 85% of it being free means that there's 85% of chlorine able to disinfect anything that the water may come in contact between the treatment facility and the consumer, to ensure that nobody gets hurt, bacteria, pathogens, or anything like that. Once again, I want to reiterate, whatever test you're doing, whenever you get your results, log them in the daily ledger sheet, and that's usually in milligrams per liter or parts per million. Once again, that's in the water world, they're universally the same. At this time, I would like you to pause this video and look over handout 1, which is just a brief run through on everything I've just touched on. water sampling setup, as well as the testing and operating of the meter. I kind of combined them all together because in order to do the testing, you have to do the sample setup and they flow together, so I thought it would be better to put them all together. Do that, read through that handout, and then look at quiz 1 and take that quiz, and then we'll pick up here in just a few minutes. Welcome back, and let's begin objective number 3, analyzing and understanding the test results. In objective 1 and 2, we set up samples and ran the test for the water treatment facility there of Louisville, Missouri. Analyzing some of the results, we'll begin with manganese. Manganese, according to the DNR, state of Missouri, has a maximum contaminant level of 0.05 milligrams per liter. Anything above that, the test should be ran again to ensure the accuracy of the testing. And then if it still is tested above a 0.05 milligrams per liter or parts per million, you need to start investigating your treatment process to look for deficiencies and see if there's something going on, why you're not removing, if your incoming raw water is higher than normal and than what it should be as far as manganese level, or if your treatment process isn't effectively treating it as it should. Then there is the iron maximum contaminant level, which is at 0.3 milligrams per liter. Once again, if you exceed these limits, go back and retest just to make sure that your test results are accurate. If they're not, go back and look into your process and try to figure out what is causing these numbers to be out of range, and if all else fails, consult DNR or your local water specialist to help resolve the issue, because in the end you want to protect your consumers and make sure that they're not going to be harmed. We also tested for the chlorine levels, the free and total. The total chlorine level is the amount of chlorine found in the sample, which includes the amount of chlorine that is being used by the sample to destroy any bacteria or pathogens during the treatment process in this sample. The free chlorine is the amount of chlorine that's not being used by other bacteria and is still available to be used in that water sample to destroy any microorganisms, bacteria, pathogens, and to also disinfect anything else that is entered into the system. You always want 85% of your chlorine to be free. Not always, going to happen, but that's what everyone shoots for adequate disinfection of newly introduced bacteria in case there's later issues with the system. According to DNR, the lowest chlorine residual allowed is 0.5 milligrams entering the water distribution system, and it should be 0.25 milligrams per liter at the end of any distribution system. So most water specialists sample at the distribution system or the treatment plant, and then go to the end of the system to ensure that they have at least 0.2 milligrams per liter or parts per million at the end of the distribution system to ensure that all the bacteria is dead and no one gets sick or ill from digesting or ingesting non-chlorinated water. These are important to ensure adequate disinfection occurs without causing negative implications to the customers. Same thing I just said. And that wraps up objective number 3. Now we're on to objective number 4, the importance and impact of each test that we just ran. Even though iron and manganese are necessary for the adult diet, most adults ingest more manganese and iron than what's required for their daily diet without adverse effects. High iron and manganese levels can impart a taste and odor problem to the customers, which you're going to hear about it real quickly, and they're going to let you know, hey, what's going on with my water? I'm concerned about it. Water contaminated with iron and manganese often contains bacteria, usually in the form of iron bacteria. High levels of manganese can precipitate out, causing black water that may stain plumbing fixtures and laundry. High iron levels can precipitate out, causing red water. High iron in water can spoil the taste and odor of vegetables, coffee, or tea. And high iron can allow for iron bacteria to grow, such as Firmicutes and Gallonella. Then we look at the chlorine levels that were tested, the free and total. Total is the amount of chlorine found in the sample, including that is being used to destroy bacteria or pathogens. Free is what's left after that reaction occurs, destroying the pathogens and bacteria that's existing in the water. So the free is what's left there, just in case an interruption occurs in your system to kill more bacteria, more pathogens, and kind of a safe net for you. It's not enough that's going to harm you, but it exists there just to protect you. Hopefully everyone knows that chlorine, when it's used in drinking water, it's used as a disinfectant, and the free to total ratio, you want 85% of the free chlorine, 85% of your chlorine level to be free. That way you've got that much left in the system to take care of any bacteria that may still exist after the treatment process. So the lowest chlorine residual allowed is 0.5 milligrams per liter or parts per million entering the water distribution system or leaving the water plant, and then a minimum of 0.25 milligrams per liter at the end of the system, with a maximum residual level of 4.0 milligrams per liter, which is highly unlikely that anyone's going to reach that, but over a 12-month rolling period, 4.0 milligrams per liter at a maximum. And most systems operate between a 0.5 and 2.0 milligrams per liter chlorine level. Some other things could be drinking water with excess levels of chlorine above the maximum residual disinfectant level could experience irritating effects to the eyes and nose, stomach discomfort, or anemia. Water with chlorine levels below the minimum concentration of 0.5 milligrams per liter entering the distribution system make it susceptible to bacteria and pathogens living in the water system, which I've already said. At this time, I'd like you to pause the video and look at quiz number 2, which is over water sampling analysis and its importance. Once you get through with that, come back and we'll finish up with the rest of the course. Welcome back, and I would like to thank you for taking the time to go through this course on how the Lilburn Water Treatment Facility operates and this does its testing and sampling of water samples, along with the results and how it analyzes those results. At this time, I would ask you to fill out the end of the course evaluation and submit it to the email included on the evaluation form. If you ever have any questions or comments or anything else, don't hesitate to comment or contact me via the email that's included on the course evaluation. And hopefully this course was beneficial to you and will help future operators for the Lilburn Water Treatment Facility. Thank you.